Okay guys, so we're basically going to graph a polynomial function today. And I know it sounds horrible and you're like, what? But it's not that bad. Okay, so let's first talk about what our basic parent functions of x squared and x cubed look like. What does x squared look like? A parabola, right? Okay, because x squared is a type of polynomial. What does x cubed look like? Yeah, the little like curvy s. So it goes like this. Okay, so when we talk about a polynomial, in general, if I have the degree of the whole polynomial is an even degree, we're going to look at the end, we're going to call this end behavior, what it's doing on the far left side and the far right side. Okay, so for even degree, the end behavior of a graph, oh, I just don't know this one page, there we go, OR, wow. End behavior is going to be up, up. So it's going to point up on the left and up on the right. And then we'll figure out what happens in the middle. So that means if I have an x to the fourth as my degree, it's still going to look the same on the end. It's just in between is going to be different. Okay, same thing over here. If I have an odd degree, which today we will not do anything more than x cubed. So odd degree, the end behavior goes down on the left and up on the right. So we'll only do x to the fourth and x to the third today, and won't go much further than that. Now these are, what's my coefficient in front of x squared? Positive 1. What if it was a negative 1? What would happen? It would flip down. So really, I could have another end behavior here, but we're only going to focus on the positive ones. Okay, so you only have to worry about those two. Okay, so let me go back to this before we do a big one. Let me go back to just a regular x squared. The one I had up there was what? X minus 2 and x minus 5. So if I multiplied that out, I would get the one that I had up on the board. See if I can explain a little better what I wanted to explain. So if I gave you this equation, x minus 2, x minus 5, and I set it equal to 0, and I said solve, what would you do? If I multiply this out, I'm going to get this, right? So really, I want to go from here to factor form. If I solve these, we're going to get to more quadratics in the spring. But I just want to show you what happens here. If I solve for x here, what do I get? Positive 2. What do I get here? Positive 5. Now do you see where I drew those 2 points on that graph on the board? Positive 2, 3, 4, and positive 5. Okay, so we're going to solve, I'll show you real quick what one might look like. Maybe this one. Everything's going to be given to you like this in factored form today. Okay, so you won't have to go from something crazy like a cubic function to a factored form. You don't have to do that. So this is just a basic quadratic function. So we're going to do bigger ones. We're going to do x cubed and x to the fourth. So what I want to point out here, do you see how at 2, the graph goes through the point? I'm going to try and darken it a little bit. And then same at 5, it goes through the graph. So we can have things cross, or let me just draw like another little picture and show you what could happen. I could have something just touch the x-axis. So I can cross the x-axis or I can touch it. This comes from the degree on the factor. So what do I mean by that? This is a factor, x minus 2. Here's another factor, x minus 5. What is the degree on just this? 1, right? X to the first. And how about this one? 1 also. So here's why I don't want you to get confused. It's kind of weird. Down here, if it's an odd degree, maybe we should say exponents. crosses the x-axis. Crosses the x-axis. So like this one, I had x minus 2 and x minus 5. It crosses the x-axis. I'm going to say this is at positive 1. So if I have x minus 1 squared, there's an even exponent. So even exponents touch the x-axis. And this is where you get what happens in between your two arrows. And I promise once we do 1 or 2, you're going to be like, oh, okay, I got it. Okay, so let's do 1. Oops. Okay, so the instructions are just graph the function. And you're going to get this big whole thing, but it's in factored form already. So really, the hard work is done for you. X minus 1 and x minus 3. So over here to the side, just draw your x and y axis. And then we're going to go through, there's only 4 things you're going to look at. So let's start with the degree. And when I say degree, I want the degree of the whole polynomial. So this first factor here, I've got 2. Now I'm multiplying, so I'm going to add this 1, and I'm going to add this 1. So what's the degree of the whole polynomial? 4. Does everyone see where that came from? These are like their own terms. When I multiply them all together, I just add exponents. Okay, so we start with degree 4. Second thing we're going to talk about is just the end behavior, because it follows the degree. It's an even degree. 4 is even. Does it go up, up, or does it go down, up? Up, up, because it follows x squared. So up, up. So what I do on my graph, I just draw 2 arrows. On the left side it's going up, and on the right side it's going up. Yeah, just as long as one's on the left and one's on the right of the y-axis. Okay, second thing, the zeros. So those just come from up here. If this is x plus 1, what is my 0? Let me go back to this. X minus 2, if I actually solve it to find the 0, I got x equals positive 2. So come back here. If it's x plus 1, it's negative 1. Good. So x equals negative 1. What's my next one? Positive 1 from here. It's x minus 1, so it becomes 1. And what do I get from this one? Positive 3. So let's graph those points. Negative 1, 1, 2, and 3. Okay, so I have to determine, does it cross or touch at these points? So look at your x plus 1 factor. It's an even. Does even cross or touch? It touches. So I just sometimes put a T here. I'm going to write out touch so that you remember. And then on my graph, I put a T. That way when I'm drawing it, I don't have to look back over here. I can just touch that point and go back up. At x equals 1, does it touch or cross? It's an odd, so it crosses. And x minus 3 is also odd, so it crosses. So I'm going to put a C and a C. Last thing, the y-intercept. And when you're doing your homework, if you want to write all this out, you can, but really, you'll start to get the information and you'll just plot it on your graph and go. What's the x value on the y-intercept? What does y-intercept even mean? Where it touches the y-axis. So what's the x value here? 0. So here, want to make yourself a note, we're just going to plug in 0 for x solve. So that just gives us one more point to plug in. So I have 0 plus 1 squared times 0 minus 1 squared, oh, not squared, sorry, times 0 minus 3. Just don't forget that you're multiplying here. So this becomes 1 squared is 1 times negative 1 times negative 3, which equals 3. So my y-intercept, 0, 3. And then graph that on your graph. 1, 2, 3. And there's my y-intercept. And now you just connect the dots. So I'm going to move my arrow a little bit. So I always go left to right. Okay, so here's my arrow. So I'm going to come down because that's where my arrow is coming from. Since I have a T here, I just touch it and I come back up and I go through my y-intercept. You always go through the y-intercept. But at this one I cross, so I actually come through it. And then I'm going to come back up to this 3 and go through it. Move my arrow a little bit. And then I'm just connected to that arrow. So I don't care how low your curve is or if it's really shallow. I don't care about that. I care about the end behavior. Did you cross or touch and where your y-intercept is? So that wasn't horrible, right? Maybe. Let's do another. We'll do another one. We'll do a couple. So on the quiz and the test, well, I'm not sure about the quiz, but for sure the test, you'll have like 2 of these, it'll just be no calculator. Because obviously you can put this in your calculator and graph it, right? So you'll just have like 2 of these with no calculator. The rest of the test though is calculator. So let's do another one. X minus 2 squared, x plus 1. I'll make my xy axis, so we're ready for that. So start with the degree. So what's the degree of the whole polynomial? 3. I've got 2 here and 1 here. So degree is 3, which gives me my end behavior. Is it up, up, or down, up? Down, up. I'll just make my arrows on my graph. So since I'm down, I'm going to come below the x-axis, down, up. So think of your basic x cubed, down, up. Okay, then the zeros. X equals what? 2. At 2, let's go ahead and look at this. It has an exponent of 2, so does it touch or cross? It touches, right, because it's even. Not this 2 is even, but because it has an even exponent. What's my other 0? Negative 1, and does it touch or cross? Cross. Let's graph those. So positive 2, and that's going to touch, and negative 1 is going to cross. And then last, you just need the y-intercept. So plug in 0 for x. So 0 minus 2 squared. 0 plus 1. And don't forget here you're multiplying. A lot of people in second period kept saying 5, but it's negative, or it's 4 times 1. So my y-intercept is just 0, 4. So draw yours and then I'll draw mine. Let's see if it matches. So go left to right though. Like on the first one we did, I always start at the left. So you should come from the bottom left, cross through -1 with a 3 or y-intercept, and then just touch at +2 and then come back up. All right, ready for another one? Let's have 2 more, I think. 3. Okay, so this is going to have a different coefficient in front of it. We haven't had one with a coefficient in front except 1. So I have 1/3 x minus 5 times x plus 2 times x minus 3. It only affects one thing. I promise. Okay, so let's start with degree. What's the degree of the whole polynomial? 3, right. So it doesn't matter if the 1/3's there or not. It doesn't change the degree. I have 1 here, and 1 here, so degree is 3. Which makes our end behavior what? Down, up. So again, the 1/3 hasn't changed anything. Doesn't affect the degree, it doesn't affect the end behavior. Do you think it affects the zeros? No, it doesn't, because there's no x there. I'm only concerned with the ones that give me an x. So what are the zeros? X equals 5. Does it touch or cross? Crosses. X equals -2. Touch or cross? Cross. And x equals +3, and it also crosses because they're all odd. 1, 1, and 1. And then lastly, the y-intercept. Does the 1/3 affect the y-intercept? Yes, because now I'm going to multiply that 1/3 in. So I use the whole function, so I have 1/3 times, and now I'm going to plug in 0. So 0 minus 5, 0 plus 2, 0 minus 3. So let's see, we've got 1/3 times -5 times 2 times -3. Which is +10. So 0. Oh, I didn't grab my zeros. I'm going to come back and grab my zeros. So -2 crosses, 3 crosses, 4, 5 crosses. And I'm just going to put 10 up here. Okay, so from left to right, crosses through -2, and then my y-intercept, crosses through 3, and then crosses through +2. Okay, this is where it might get worse. Oh, God. It's not horrible, it just has factoring in it, which we've been working on, so hopefully it's not so bad. Number 4, f of x equals x minus 3 times x squared plus 2x plus. It's not even a bad factoring one, though. So on this one, you have to factor this first. So factor that, and then see if you can come up with your graph. adds to give you 2, multiplies to give you 1. Did you get your 2 factors? What did you get here? X plus 1 and x plus 1. Now, since we're concerned with our degrees, really I want to rewrite this as x plus 1 squared, because I need to know this too, because it affects the graph. So now this is what we're going to base all of our numbers off of. So see if you can graph this one. Okay, so this is a little bit different only because you have a negative y-intercept, but nothing else is really weird about it. So start from bottom left, you touch at -1, and then go through your y-intercept, and then cross at positive 3. How'd you do? Good? Okay. We're going to go backwards now, but there's no graphing involved here. As soon as I find, I'll have pictures of myself. Here it is. And I want to give you a little time to work on some of those graphs that you have. Okay, so the last thing. So instead of giving you factored form, I'm going to give you the zeros, and you're going to put it in factored form, and then you're going to go to standard form, which just means multiplying out. That's all it is. Number 1. Put my numbers in there for you. -3, +1, and +2. So if you're given the zeros are x equals -3, x equals +1, and x equals 2, I can take this now. Let's put it into factored form first. What would the factor be for -3? Perfect. X plus 3. Then I have x minus 1, and then I have x minus 2. This is factored form. Okay, make sure you know the difference. Because on your worksheet, I think 2 of them are factored form, and then the others are standard form. So whether I give you a graph or I just give you a list of numbers, you should be able to get to here. How do I put this in standard form then? Let's just multiply. So I'm going to take these 2, just take 2 at a time, or 2 first. So I'll just FOIL. This becomes x squared minus x, or whatever you call it. Some of you don't call it FOIL. Plus 3x minus 3. So x squared plus 2x minus 3. But then I still have to multiply it with that x minus 2. So I'm going to go from the x to here. So as long as it's the same answer, it should be fine. X cubed. X cubed minus 7x. So it's no graphing involved. It's just if I give you either the 3 zeros or 4 zeros, or I give you a graph, just take those. Remember to change the signs in your factors, and then just multiply it out is all you have to do. Just make sure you pay attention to, is it factored form or is it standard form, which is this one. I wouldn't want you to do more work than you have to, but then I don't want you to get counted off because you didn't do enough work. Okay, so the rest of the time is yours. My key's in the back. But I would definitely practice a few of those graphs.